During positive off cycle, so during positive off cycle, so this is the positive off cycle. We are discussing now during positive off cycle, it is like this. So the way, what will happen to current, where all current will flow, we'll just break up this current, call I1. And also there'll be I2, no? The capacitor will get charged. I will take it out all this, huh? This may not, later on if needed, I'll introduce. Let me have first give the clarity of the diagram. We'll agree this. During positive off cycle, this end of signal will be, right, 240 volt, 50 hertz. No, during positive off cycle of signal, what will happen to this end? This end will be positive. This primary will be positive. This will be negative. Second will be positive. The diode will be forward biased, and the current, and it starts conducting. Current will flow. Even as this current flow, there'll be a drop, and because of that, the capacitor gets charged here. So during positive off cycle, what is the state of capacitor? Capacitor will agree this. I think you know enough of RC circuits problems. That only I'm taking help this one. During negative off cycle, what will happen? During negative off cycle, what is the state of diode? Diode will be reverse biased. I think complete diagram is visible. Yeah, fine. So capacitor here gets discharged. During negative off cycle, I'm bringing this one. Now, what should happen to the polarities? The polarities will take negative, positive, negative, positive, negative. This is a positive. What is the state of diode? Diode is reverse biased. In place of diode, off, or reverse bias it is. Then will there be any current through the resistor? During positive off cycle, what happened to capacitor will get charged, no? Will get charged. Then the moment negative cycle arrives, the diode will be reverse biased. As the diode is reverse biased, what will be this charged capacitor when you connect across a resistor? This capacitor will behave like a source. So now it starts discharging. Tell me, like, in what direction it will push the current? In what direction it will push the current? In what direction it will push the current? It will push the current in this direction. This is a discharging current. ID, let me write it. Positive, negative. This will be positive, negative. Look at now. This during negative off cycle, without capacitor, what will happen? No current here. No, because of this capacitor, presence of capacitor. During negative off cycle, who will make the current to pass through the diode? Who will make the current to pass through the resistor? This capacitor start discharging. How long it will discharge? Till what will happen? Another positive cycle arrives here. So like that, during positive off cycle, capacitor gets charged. During negative off cycle here, what is the state of capacitor? Now tell me, like, capacitor gets discharged. So if you don't take this ITG coaching or JEE Mains, just you are learning in one ordinary college. You go to any Kendra Vidyalaya, CBSE or state board, many colleges are there, no? You can see that. Then what happened? Things will be very simple. Huh? Just now I told nobody will discuss this. Nobody will discuss. That's what just now I concluded. The what is then book. There they'll stop it. Finish all. Okay, fine. Somehow what when you prepare this that you'll get a rank and you'll enter into some college. What we have some colleges I don't know here. CBT, Vignan, so many are there like some 10, 15 top colleges in Hyderabad. They say okay, fine, you'll get there. When you go to the engineering, suppose you pick anything related to electronics, that one, what the professor, he will not explain like what I'm explaining. He says that during positive off cycle capacitor will charge, during negative off cycle capacitor discharges. A student, when he don't know properly RC circuit charging discharging, tell me how he'll understand this rectifier. Will not understand. This is a basic circuit in the third semester. Like that, what happened? The diode forward bias, reverse bias. Okay, forward bias short circuit, reverse bias open circuit. But how to solve the diode circuits, everything, you don't know anything. Literally, what happens, students, what happens, they lose everything. Without thinking ability, they're entering into engineering. They're what happen, again, question, answer, question, answer. Finally, they'll come out, okay, some 10, 15, 20,000 job will they'll get, and they're happy. Where is the root cause? Shall we scold our engineering colleges? No. We have to scold our the high school starting from 8th, 9th, 10th, 11th, 12th. Here, what happen, you are not making students to do numericals. You are not permitting students to think on their own. Just like information they're gathering and they're going there. If you know factory, can you work in a factory? If you know address of factory, can you go and work in factory? Can you do research? No, not there. No, there's a thing. Why we are lagging here is the basic science. We are totally off the show. Those students at least they take the JEE mains or advanced coaching, so some extent they know charging, discharging. If IT, if you get into even in by chance, if you don't get into even ITs, NITs, if you are in some top colleges, 10, 15, there, if the professor says charging, discharging, then immediately, oh, charging, discharging, Sridhar sir used to teach some charging, discharging. Then you start thinking, analyze, you are on track. So what is the root cause? In every college, what happen? There should be a discussion of numericals. Then only what happen? A good thinking engineer, thinking student will join engineering college. Then lot of changes will come. So this JEE advancements should not be confined to top one batch, top two, three, top four, that one. Even in the remotest villages, if a teacher teaches to a large extent numerical analysis, everything, no, it's definitely everyone, every student will acquire knowledge. Every student starts thinking, things will change. Tell me for this, what we are doing? We are doing nothing, no? What government is doing? Nothing. What about other things? Nothing, no? There no any, the way how sun rises, sets, the similar way things are going on. Nobody is bothered about anything. Unless you don't set right things, not possible. Huh? See, like out of 10,000, how many good engineers are coming? You know that only 200 again. 10,000 students will join IT. Only 200. In that 200, again, core research only around 15 to 20. Okay, those all they'll get migrate to abroad. Who will develop India? Nobody is there. That's why we are like this only. Root cause. So why I'm telling you these things are why we are not related, because some of you, I think after IITs, some of you are showing interest in to become IES, Indian Engineering Service, Indian Administrative Service. When you pick up, no, when you become such collector or very big good position, then one finally will be appointed as the advisor for the government of India, because only IAS can give advice to the government. At least, okay, you may change. That's why I'm with that hope. I'm sharing my concern with you. Okay, let's get into this one. So there's some sort of charging, discharging occurs, no? Okay, let's see that. This is not something anybody can learn. It's not that since I did BTech in this one. Just if you have basics, you can apply. What is there in this one? Let's check the graph of this. How this graph will be. Let's come for the plotting graph. So during positive off cycle, like this you can continue. So it'll come one more cycle like this. No, what is our original graph? The original graph will be like this. Here what happen? Till here it gets charged. Afterwards what happen? It will discharge. Again next cycle will come. You can see that again the next cycle. So it'll get charged. Then again it'll get discharged. What was our goal? Some horizontal line was our goal, no? So this is now the output. The output VL, what we are expecting, will be of this kind. So what is this? This phase is charging phase. You can write it. This part is what charging. And what about this? Discharging. Like this, the earlier, the one which was horizontal, now what happened to, oh, this is good, no? You compare this and this. This is what? Without filter. What is the filter? The capacitor is a filter. This is with filter. What filter is doing? It is eliminating AC. Filter means what? When it eliminates AC, that one. So how it eliminate? By this particular thing. So earlier you look at this one. Earlier the signal was like this, no? No, what happened? You see this? Somewhat better, no? But sir, like if we wanted something horizontal, S. Okay, now go back to the RC circuit. If you increase RL, there's a discharging, no? If you increase RL, what is the time constant? RLC is a time constant. If you increase RL, it will take more time to discharge, no? Then the curve will become flat. For higher values of RL, this will become almost flat. Then I'll use another circuit where I can small that spikes are there, no? This one that I'll eliminate. Like that, I'll get a constant voltage. So you open that mobile charger, no? You see one capacitor. Instead of two diodes, you see four diodes. Bridge rectifier it is used here. Then you see one resistor, then Zener diode. Everything will be available. Again, don't break the new one. Any old one not working, no, you just open it. You can see all the things. Or type in Google or YouTube. You can see the video. Better you see physical. It'll be better. Okay, now I want that particular the mathematics involved with this. Let's get into the mathematical part. Now, what is it? There's a peak voltage. Small expression is there. I'll give it. This let me take P. And what is peak voltage? That Vs only is what V peak. Let me use this one here. No, it's going to undergo discharge here. No, I'll come to the next derivation part. This will I'll just let me give color. It'll be easy for us. Huh? Charging, discharging one. This is the our signal VL, and this is the peak. Okay, let's come for this. There's a discharging phase, no? I think this also will not be there. Even this solid line should not be there, no? So try to look at only that red and blue color solid one. Charging, and this will be charging. And discharge, like this it will continue. So almost we obtained horizontal line. Of course, not horizontal, but still good, better. So now what is this discharging voltage should be equal to? Shall we put e to power of minus t RLC? Go back to the where RC circuit discharging, and the exponential term. What is the e to power of x? When you expand, what you get? 1 plus x square by 2 factorial, x cube by 3 factorial, and so on. So if I expand this, e to power of minus t is there. Neglecting higher order term, so shall I write only t RLC? Agree this formula, expanding that e to power of minus x formula and substituting and neglecting higher order terms will end up this one. Is it okay? This is neglecting higher order terms will end up this one. So this will be VL equal to VM. So what is that VL minus VM? Let me take it only V. So this will become VMT RLC is equal to VM minus V. What is that VM minus V? That is the fluctuation, delta V. So what is the fluctuation you are seeing? We are seeing the, and I'll show it here. Is that okay? So this was the fluctuation. No? So if you just go for horizontal line, so like this, a small fluctuations are there. You can see that this part here, fluctuation. So what is the delta V is what equal to this one. So now the ripple factor, we define this, we denote by symbol like a gamma like this. This is equal to fluctuation by the peak value. So what is the fluctuation by peak value should be equal to T by RLC. What is this T? T is what? I'll define from here to here. There's a one time period of that signal only. So this will become T by RLC. Tell me like this ripple should be more or less. If ripples are more, delta V will be more, no? If ripples are less, delta V will be less. And what is the ripple factor? Given by fluctuation by the peak value. Able to analyze this? The fluctuation by peak value is called as a ripple. So then to minimize ripple factor, what shall I do? I can't disturb T, leave it. So what to do with RL and C? C is a fixed here. So RL, S, shall I increase? S. So as I keep on increase the load, we'll get almost horizontal line. So for higher values of RL, gamma will minimize. If gamma gets minimized, means ripple gets minimized. If the ripple gets minimized, means no fluctuation, and that is what the required DC voltage. So with for higher values of RL, the signal will be of like this. Almost it will be a straight line. This is for high values of RL means how much? Around 10,000 ohm. That is enough. 10 kilo ohm. That is enough. For higher values of RL, the signal will become like this. For lower values of RL, how it will be? We can see some fluctuations here. So there's a charging phase. This is for, see, everything is in one systematic thinking here. So therefore now to get that required DC voltage, what I should do? So make RL or C large. Then with that, what will happen? We can get the required voltage. This is what required output. Got this? So what is that capacitor? Shall I call it as a filter? With filter, without filter, it is called as. So what is the capacitor? The capacitor is called as a filter. Again, different types of filters are there. With inductor also, with inductor, capacitor, two capacitor inductor, that also will become filter. The same role they'll play it. I just took one basic thing to show you that how to minimize that ripples here. So for rectifier with filter, what should be the expected value of time constant? The RLC. The RLC should be large enough so that the ripples can be minimized here. So that we'll get a required output voltage of this kind. This is the thing not there in books, so possibility of asking, you have to remember. So to minimize ripple, what happened? The time constant of the RLC circuit should be more. L means not inductor here, load RL. The load resistance is given symbol RL. Or high capacitance is preferred or high resistance is preferred. The product of that should be I. Then the ripple factor will be minimized here. This one, so one more efficiency will go for it. Last one. Efficiency of full wave rectifier, off wave rectifier.